Hello everyone. In this video, let us solve some problems on bivariate CDF, mean and correlation. First problem, a bivariate random variable has the following CDF. CDF is given as fxy x comma y is equal to c into x plus 1 whole square y plus 1 whole square for all the values of x varying between -1 to 4 and y between -1 to 2 outside of the given interval. The bivariate CDF is required by theory. What value C must have? Find the CDF fx of x and fy of y. Find the bivariate CDF. Evaluate probability of x less than or equal to 2 intersection with y less than or equal to 1. Fifth one, are the bivariate random variables independent? Given CDF fxy, we let us put the two extreme conditions of x and y, that is 4 and 2. So therefore c into x value is 4, 4 plus 1 whole square, y value is 2, so 2 plus 1 whole square, that should be equated to 1. So we get the value c is equal to 1 divided by 225. In order to get the CDF, let us try to bivariate CDF. Let us try to differentiate fxy, the CDF, once with respect to x, second time with respect to y. When we do this, we get the answer as 4 divided by 225 into x plus 1 into y plus 1. So therefore, we need to find out fx of x, that is equal to integration of bivariate CDF with respect to y, the limit being -1 to y. So bivariate CDF is given by 4 divided by 225 x plus 1 into y plus 1 dy. So we get the answer as 2 divided by 225 x plus 1 into y plus 1 whole square. The limit for y, the range for y varies between -1 to 2. Similarly, let us find fy of y, that is we have to integrate the bivariate CDF with respect to x. So it is 4 divided by 225 x plus 1 into y plus 1 dx. And when we do and substitute the value, that is -1 to x, when we substitute the value, we get 2 divided by 225 y plus 1 into x plus 1 whole square for all the value of x between -1 to 4. And we need to find out the probability of x value less than or equal to 2 intersection with y value less than or equal to 1. So fxy is equal to 1 divided by 225 x plus 1 whole square y plus 1 whole square. So therefore it is 1 divided by 225. X value is 2, it is substituted here. So we get 2 plus 1 whole square, that is 9, and y value is equal to 1. So it is 2 square, so you get this as 4. So the answer is 4 divided by 25. And you can observe here fx of x and f multiplied with fy of y will not give us the bivariate CDF fxy. So we can say that x and y are not independent random variables. Let us move on to the second problem. The mean and the variance of the random variable x are -2 and 3. The mean and the variance of y are 3 and 5. The covariance of xy is equal to -0.8. What are the correlation coefficients rho xy and correlation expectation of xy? Rho sigma x square, that is variance of x, is given as 3. Mean mu x is given as -2. Sigma y square, that is the variance of y, is given as 5, and mean mu y is given as 3, and the covariance of xy is given as -0.8. Covariance of xy is given by rho xy sigma x into sigma y. Sigma x is root of 3 and sigma y is root of 5. So that has been substituted here, and covariance of xy is given as -0.8. So the answer is -0.2066. Expectation of xy is given by covariance of xy plus mu x into mu y. That is minus 0.8 into 2 into that is minus 2 into 3. That is equal to minus 6.8. Problem 3. X is a random variable, mu x equal to 4, sigma x equal to 5, y is a random variable, mu y is equal to 6 and sigma y is equal to 7. The correlation coefficient is minus 0.7. If u is equal to 3x plus 2y, what are variance of u, covariance of ux and covariance of uy? And let us try to find out covariance of xy, that is given by rho xy into sigma x into sigma y, that is minus 0.7 into 5 into 7, that is minus 24.5. So we can find out mu u, that is equal to a into mu x plus b into mu y. So therefore it is 3 into mu x plus 2 into mu y, and 3 into mu x is 4, mu x is 4 and 2 into mu y, that is 6. So we get the answer as 24. Sigma u square, that the variance of u is equal to expectation of u minus mu u whole square. But we know the expression for mu u. Let us substitute here. Mu is given as 3x plus 2y. Mu u is 3 mu x plus 2 mu y. So when we expand it and when we simplify, we get this as expectation of a square into expectation of x minus mu x whole square plus 2ab expectation of x minus mu x y minus mu y plus b square into expectation of y minus mu y whole square. That is equal to this expectation of x minus mu x square is sigma x square. So therefore it is a square sigma x square, and it is expectation of x minus mu x y minus mu y is the covariance of xy, and plus b square into sigma y square. Let us substitute the value, and when we substitute and calculate, we get sigma u square is equal to 127. Variance of u is given by 127. U is equal to 3x plus 2y. So therefore coefficient A is 3 here, coefficient B is 2, and x equal to x, and so therefore C equal to 1, B equal to 0. So let us use this formula to calculate covariance of ux. It is given by AC sigma x square plus BC plus AB covariance of xy plus BD sigma y square. When we substitute the values of A, B, C, D, sigma x and covariance xy and sigma y, we get 26. Similarly, we have been given u equal to 3x plus 2y, that is A equal to 3, B equal to 2, and y is equal to y. So C equal to 0, D equal to 1. Let us substitute the values of A, B, C, D in this equation and simplify. We get covariance of uy is equal to 23.9. Problem 4. X and y are correlated random variables with correlation coefficient rho is equal to 0.6, mu x equal to 3, variance of x equal to 49, mu y is equal to 144, variance of y is equal to 144. The random variable u and v are obtained using the relationship u is equal to x plus vy, v equal to x minus vy. What values can C have if u and v are uncorrelated? So in case of to find out this, we need to first find out covariance of xy, and rho xy sigma x sigma y, that gives you 50.4. So variance of uv is equal to this we have to equate it to 0, because we are saying that they are uncorrelated. So therefore we have to equate it to 0, and we have to make a substitution for a value, c value, and d and b value, and we can get these values here. A value is equal to 1, b value equal to c, and c value is equal to 1, d value is equal to minus c. That has been substituted here, and we equate it to 0. We get c value is equal to plus or minus 0.5833. We take the fifth problem. The zero mean bivariate random variable x and x2 have the following variances. Variance of x1 is equal to 2, variance of x2 equal to 4. Their correlation coefficient is 0.8. Random variables yn and y2 are obtained from y1 is equal to 3x1 plus 4x2, y2 is equal to minus x1 plus 2x2. Find the values of variance of y1 and variance of y2 and covariance y1, y2. Covariance of x1, x2 is equal to rho x1, x2, sigma x1, sigma x2. You get this as 2.2637. Because the variance is given as 2, so therefore standard deviation will be root of 2. Here the variance is given as, in the case of this is 4, so therefore standard deviation is root of 4. y1 is equal to 3x1 plus 4x2, so a equal to 3, b equal to 4. y2 is equal to minus x1 plus 2x2, c equal to minus 1, d equal to 2. Using the equation, sigma y1 square and sigma y2 square can be found out using these two equations. Let us make the relevant substitution. We get sigma y1 square is equal to 136.3, sigma y2 square is equal to 8.9492. So covariance of y1, y2 can be obtained using this equation. So let us substitute the values of a, b, c, d in the equation, and we get the answer as 30.5254. Thank you. In the next video, let us solve some more problems.